Hi everyone, and welcome back to my Basics of Flight Mechanics class. So today we're going to be covering the 3 degrees of freedom EOMs, and that will conclude this chapter, and in order to do that, we're going to be deriving the inertial acceleration. So it's always good to keep in mind what you're doing. An EOM is an equality, which means that you have a left side and you have a right side. In the previous lecture, we figured out the sum of the forces, and more precisely, the sum of the forces in the wind axis system. Now we have to figure out the other side of the equality, and that would be the inertial acceleration. So we know that the acceleration is equal to dv over dt, and that the velocity vector is already defined in the wind axis system. So all you have to do is to take the derivative of the velocity, and you'll get v dot of iw plus v times diw over dt. Now, in our first lecture, we had figured out that diw over dt is equal to minus gamma dot times kw. And all you have to do is to plug this in, and there you have your results. You can see that the acceleration is actually split into two main parts. There is the acceleration along the velocity vector, or the tangential acceleration, and then there is the acceleration normal to the velocity vector, or centripetal acceleration. That last part is actually what creates curvature in the trajectory. So now, thanks to all of that, we can actually establish the equations of motion, and at the very top, you have your sum of the forces tangent to the flight path equal to the mass times the tangential acceleration. At the bottom, you have your sum of the forces normal to the flight path equal to the mass times the centripetal acceleration, and at the very bottom, if you divide the right side by mv, you will get the angular velocity of the velocity vector. Now that you have all of that, you can establish your 3 degrees of freedom EOMs. So you have your horizontal and vertical velocity equations, your tangential acceleration equation, the angular velocity of the velocity vector equation, and the rate of change of the weight of the aircraft as it burns fuel. So C is the specific fuel consumption, and T is the thrust. You will notice that the gamma dot equation has its signs for the thrust, lift, and weight that are flipped, and the reason for that is because the author made this choice to make it more intuitive. It is basically written in terms of what increases or decreases gamma. So thrust and lift increase gamma, while weight decreases gamma. That's it for today. Thank you very much. See you next time.